Find the acceleration of the moving object and distance traveled during the following time intervals. You have 5 time intervals. The duration of each interval is 5 seconds. The whole travel can be divided into 5 parts. The first part, the second, the third, the fourth, and the fifth. We have to find acceleration and distance traveled during each part. This interval is 5 seconds. Other intervals have the same duration. So, if you consider the first interval, we can say that speed increases linearly. That is why we can say that this is uniformly accelerated motion. And to find acceleration, we can use formula A, acceleration, equals final velocity, or in our case we can say final speed, minus initial velocity or initial speed, because velocity doesn't change its direction, over time interval delta t. The first segment, acceleration, is final velocity 30 meters per second minus initial velocity 0 meters per second divided by 2 seconds. And we have 6 meters per second squared. To find distance traveled, the most simple method is to find the area under the graph. The area under the graph is the area of triangle. So, S, distance traveled, is half of height of triangle times base. 1/2 times 30 meters per second times 5 seconds. It gives 15 times 5, 75 meters. The next segment, the next time interval from 5 to 10 seconds. The speed is constant. It's a uniform motion. That is why we can say acceleration is 0. And to find distance traveled, A1, S1, A2, S2, to find distance traveled we can multiply speed times time. 30 meters per second times 5 seconds, we have 150 meters. The third segment of motion, this segment is motion with uniform acceleration, or it may be better to say uniform deceleration, because speed decreases during these 5 seconds. So let's use this formula. A3 equals delta t, 5 seconds. Final velocity 15 meters per second. Minus initial velocity 30 meters per second. It gives minus 3 meters per second squared. Minus 3 meters per second squared. S3. Let us find this distance as an area under the graph. This area is the sum of area of triangle above and rectangle beneath the level of 15 meters per second. So the first part, half of height, the height is 15 meters per second. Times base plus the area of rectangle, 15 times 5. 15 meters per second times 5 seconds. Seconds dividing out, and we have 75 plus 37.5 plus 75 meters. It gives 112.5 meters. The fourth segment, A4, uniform motion, acceleration is 0. Distance traveled, speed times time, or the area of this rectangle, 15 meters per second times 5 seconds gives 75 meters. 75 meters. And the last, the fifth segment, uniformly accelerated motion. We have deceleration because speed decreases, and let's find the area under the graph. To find distance. To find acceleration, A5 equals final velocity, final speed 0 minus initial speed 15 meters per second over 5 seconds gives minus 3 meters per second squared. Minus 3 meters per second squared. And the last, distance traveled, S5 equals 1/2 of height, 15 meters per second, times base of the triangle, 5 seconds. Seconds are dividing out, and we have 37.5 meters. 37.5 meters. An interesting thing. The third segment, acceleration, is minus 3 meters per second here. And the last segment, acceleration, is the same. And you can see that the slope of this line segment and the slope of this line segment are the same, because the slope determines value of acceleration. The problem is solved.